the hell didn't I label these? Okay, try it now.
That's it. Okay. We're calling this the parallax-driven holographic display.
Turn your key, sir!
Oh, God. I don't think that was close enough. Matt came up with a startup sequence that makes it a little bit more dramatic. Hey, there's a dog. Hey, Harold.
So because someone put this in the electrical socket or the wrong key or something, it got super melted. That means that it doesn't work. We got a bay of lights here, a bay of lights there, that once you've figured out the pattern on that one and you find the hints for this one, you can
blur this out.
Yeah.
Pixelate the solution.
Get that one started.
These panels are half-inch Sintra, so it's half-inch PVC with pocketed rare earth magnets, and the same thing's true for the pedestal itself. So this guy just snatches in place. It's an easy remove, and these things are solid material. There's nothing to chip off of these. It's a solid chunk of plastic.
Here we are back in the guts of the command console. We have a 200 watt, 12 volt power supply that goes to the Arduino and then off to the proto board, which powers pretty much everything. Over here, you can see we still have some stray leads. We're going to have some RGB stuff tied into that you'll see pretty soon, because we're working on templates for that at the moment. So the RGBs to come. Everything else is running up. We have the LED tapes running off of one of these MOSFET transistors, so that we can control the 12 volts of that with the 5 volts coming off of the Arduino. Big monster 200 watt power supply, because we're going to be running just shy of 20 feet worth of LED tapes, 4.4 watt per foot LED tapes. That adds up quickly because math.
So we're making up the bezels that are going to go around the displays. There's going to be 2 displays, and each one's going to have one of these. And we've got this 1/8 inch, 1/2 inch, something or other aluminum channel. And currently, I am putting little L brackets in it, screwing them in with these 45-degree miters. That way, when they go together, we'll have a bezel.
We're about to start welding. I have made a template that is the same dimensions, actually the same cut path as the etched acrylic that this is going to be lighting up. I don't want to melt my acrylic. I don't care if I melt this because it's scrap Sintra. So I'm using this as my template to make sure that my brackets are going to be in a good place when the weld is done, and make some sparks. First I gotta clean it though.
So we've got our
Hang on, I'm coming closer.
our channel
There we go.
with LEDs around the inside.
Put up some so you get over the.
Yep. And an exit hole for the wiring. We're trying to very gently slide this in so we don't crack an LED as it goes.
It's a very real possibility.
Once it's in place, should be pretty safe. Our etch surface on each panel will go in the back of the panel. Tiny bit of pressure. So then after the panel slides in, the last of the LED tape and its bar gets assembled into this frame. This is a heavy duty 1/8 inch wall aluminum U-channel that we're using. It's made to be structural and beefy because escape room, beefy. We've got internal brackets on the top, and on the bottom we've got little L braces that go in the back and hold it all together. Just minimal hardware, but this is not like a lightweight aluminum picture frame. This is much heavier than that.
We're using just regular Cat5 cable for our power on this, on the RGB. Cat5 has 6 wires, 8. Cat5 is
17.
A lot of wires. Cat5 has 8 wires coming out of it. There's a regular color and there's a white striped with that color. And we have the top section and the bottom, just single leg, are on different lines here. And this is pretty convenient because it's already bundled. We're not running a million miles of various 23 gauge wire. We just have the Cat5, and at 24 gauge, I think, 26 gauge, it's plenty just to take the 12 volts of DC. The interior dimension of our U-channel is 1/2 inch, and our acrylic is 3/8, which means there's an extra 1/8 of an inch we have to do something with. So we cut these little, we're calling them chiclets for some inexplicable reason. And they're taking up our rest for space there. They're a little small because it's PVC is not actually 1/8 inch, it's 3 millimeters, so it's got some wiggle room, but that's okay. We're using some nice long 6-inch 1/4-20 bolts here that are going to serve both ends of our spacing on the final rig.
Oh, it fell right out.
Step number next is the spacers. They're going to create the distance between the 2 layers and give it that nice full dimensional effect. And you can buy pre-made spacers, and they are really unnecessarily expensive.
You buy steel bushings. These are just, yeah.
They vary somewhere between like $1.50 and $4 a piece, depending on what material and what you're getting. Or you can just get a big tube of aluminum and cut them down to 2 inches, which is what we did.
The chiclets are then acting as a pad for each one of these points where the bushing slides on. This is, again, the build-up sandwich to show how we assemble the whole thing, and the whole thing ends up balancing dead center on the frame, so that there's no cantilever. It's just an even hang, which means there's no stress on the plexiglass. Or the plexiglass is not trying to crush the LEDs. This frame is the only weight on the LEDs, is the frame itself. I'm cleaning between every step, even though we are a dust factory, and these things will get dusty before they get delivered. This is an anti-static coating as well, so it should help the dust that does collect on here, we should be able to blow it off and dust it off pretty easily, as opposed to having it just glue itself to the acrylic. With anybody who's ever worked with acrylic will know it's like electrical glue. All right, so that was another layer of bushings. Our second Plex frame, wired and ready to go, all bound in. Another layer of chiclets, and then the final bit right here is putting nuts on the back of it, using the chiclet as a washer here, and pad. Look.
Steel frame, aluminum spacers off the other side of that one, bolt running through the whole thing, and then with the little mini pad spacers and the acrylic. So you have those two are basically balancing the whole thing on the extra sturdy welded steel frame. Extra acrylic is wrapped in the aluminum bezels, which have lights inside of those. And there it is. I'm going to light it up now. It's going to look cool.
We're calling this the parallax-driven holographic display.
And it is on the short list of the coolest things we have done to date.
I think the coolest thing we've ever done for live.
This is cool.
So we've got our holographic display. Here is parallax insert shot, and it is transparent, which is brilliant. And as you walk around the room and your eyes shift and your perspective shifts, so does the piece because it's freaking holographic.
This is cool. I'll be here in space with my thing.
And this is part of the puzzle dynamic, and the buttons work, the key works to light it up. There is more puzzle stuff. You actually have to hotwire all these things in addition to the keys, and there's layer upon layer upon layer in this. These will not be in the same place as they are right now. These will be in different stations throughout the room so that you can't just go from one to the next. This requires multiple people to operate, and I'm talking really fast because I'm incredibly excited about this.
Find where we put the button and click it for the likey, subscribey, and share, because this is cool. Admit it. This is cool.
If you like it, subscribe, and yeah, share it out with your friends, because
I just said that.
You did say that.
I just said that.
We should.
I'm going home now.
Damn it.
According to this, the turn at Albuquerque was actually correct, or we're being shot at. Oh God, it's B.